Here we are at the class activities for lesson 15 of Math 107 College Algebra. We're returning to that same fruit fly problem that we just worked on in the demo. Suppose that the scientist is now comparing the original population P to a population that progresses through its lifespan twice as fast as the original population. In other words, this new population R will progress in 1 hour the same amount the original population did in 2 hours. And in 2 hours will progress as much as the original population took 4 hours to do. I'm going to sketch a graph of this population. So it'll be helpful to write some symbolic stuff. So R of 1 equals P of 2. That means it takes 1 hour for R to be at the same value that it took 2 hours for P to be at. And R of 2 equals P of 4, and in general, R of t equals P of 2t, doubling, takes twice as long. All right, so let's see, R of 1 equals P of 2. So this graph here, this is my graph of P right now. The black line is P. All right, so P of 2 I can find by finding 2 on the x-axis and going over to y, which is like, oh, I don't know, 1.8, something like that. And then R of 2 is the same thing as P of 4. So I find 4 on my x-axis, go over to the y, 2.8. So let's just get a few key points here. Let's see, I want to do T and R of t. And R of t is P of 2t. Okay. So I'm going to do some key t's here. I want 0, and this corner point here, that happens when t is 3. This point here happens when t is 6, and then it hits the x-axis again at 7. So those are some key times for the original population. I want to figure out at those times, what's the value of R of t, the new population that grows twice as fast. Okay, so at 0, R of t is P of 2t. So t is 0. So 2 times 0 is still 0. So P of R of 0 is P of 0, so it's still 1. Now when t is 3, R of 3 is the same thing as P of 6. And then I can find the value of P of 6 by looking at my graph of P, right? I go up here and I get my y value is 2. All right, I'm going to erase that. Now, when t is 6, I want to know R of 6, the R value at 6. That's P of 12. And 12, I don't know, there is no P of 12. So 6 and 7 I can't figure out, right? They just don't exist. So what can I do here? Okay, so I can't do this one or this one because I don't have P values big enough. So what I could do though is the halves of those. I already did the 3, but what if I did 3.5? If I do 3.5, R of 3.5 is P of 7, right? And I know P of 7 is 0. So that's one more point. I have 3.5 comma 0. That goes there. And then maybe I could do 1.5. So I want R of 1.5 because that's P of 3 and I know P of 3. P of 3 is 3. So I have 1.5 comma 3. And now I have my 4 key points. Right, so it looks like this. It looks like my original graph of P, except there's a horizontal shrink by a factor of 2, right? It's half the size it used to be because it grows twice as fast, which means that over time, the population graph shrinks horizontally. So using the language of transformations, we would say the effect on the graph of the original function p is a horizontal shrink where all input values are half their original distance from the vertical axis. All right, next problem. I have g of x is a transformation of f. And the graph of g of x, I'm going to describe by choosing some of these. I won't fill them all in, but I'm going to describe what each of these transformations does. So I'm going to work left to right. That's a pretty safe bet, because then you'll always be doing your two shape changes first, followed by your two shifts. So if you just work left to right, you don't have to really remember anything about the order. So this 2 times f on the outside is a vertical stretch. It's outside, so it's exactly what you expect. Vertical stretch factor of 2. Right? And then this 1/4 on the inside, it's inside f, which means it's horizontal, and it's the opposite of what you expect. So my expectation is that when I multiply by a number less than 1, things get smaller. But really what's happening is things are going to get bigger. This is a horizontal stretch by a factor of the reciprocal. Instead of multiplying by 1/4, we're going to multiply by 4 in order to make things stretch. This minus 3, that's still inside f, so it's the opposite of what you expect. Addition and subtraction move you horizontally or vertically. Inside it's horizontally, and it's the opposite of what you expect. So that is a right 3 units. And then this plus 4, it's outside, which makes it a vertical shift up 4. All right, so I'm just going to fill in. All the y values shrunk by a factor of, that one does not apply because the y values are getting stretched. All the y values are stretched by a factor of 2. All the x values are shrunk by a factor of, that doesn't apply because the x values are stretching. All the x values are stretched by a factor of 4. All the y values moved up 4. They did not move down. All the x values moved left. That didn't happen because they moved right 3. Okay, so here I have a picture of f, and I want to sketch a picture of g. So I'm going to plot some important coordinates, and then I'm going to change the x and y coordinates according to the transformations in this formula. Okay, so first I'm just going to jot down some important points here. So A is -6, 5. B is -2, 1. C is 0, 7. D is 2, 3. And E is 4, 5. All right, I'm going to sketch, I'm going to jot down 1/2 f of 2 times x minus 2 minus 1. Okay, so first I'm going to do my shape transformations, which are the multiplications. Okay, transform the x coordinate. To change the x coordinate, you're looking at what's happening inside the parentheses, inside of f. So my shape change is this 2, my shape change for f. It's inside, so it's the opposite of what you think. And so this is a shrink by a factor of 1/2, horizontal shrink by a factor of 1/2. So I'm going to take half of all my x coordinates. So my -6 becomes a -3, -2 becomes -1, half of 0 is still 0, 1, and 2. Change the y coordinate by changing its shape. That's my 1/2, right, on the outside. That's exactly what you expect. You're going to take half of all the y coordinates. Okay, so I have 2.5, 1/2, 3.5, 1.5, 2.5. I'm just taking half of all the y's. Next, I do my shift transformations. That's your -2 and your -1. The -2 tells you to go right 2, which means add 2 to the x coordinates in order to go right 2. So I'm going to add 2 to my transformed x coordinates, these guys. Okay, so -3 plus 2 is -1. -1 plus 2 is 1. 0 plus 2 is 2, 3, 5. Sorry, 2 plus 2 is 4. All right, to transform the y coordinate, that's this -1. It's outside, and it's exactly what you expect. Just take 1 away from your y's, from your already partially transformed y's. Subtract 1. So I have 1.5, -0.5, 2.5, 0.5, and 1.5. Just take away 1. So these are my final point, -1, comma 1.5, and 1, comma -0.5, etc. And I'm going to plot them. So -1, 1.5, about right there. 1, -0.5, about there. 2, 2.5. 3.5. And 4, 1.5. So when I connect these, there we go. There's my new graph. Still looks like a W, but it's been its shape has been changed, as well as it's been moved. Here we have a table of values for F. We want to create a table of values for G, a transformation of F. And G is 2 times f of 3x plus 1. So there are 3 transformations taking place. We're going to start with the horizontal transformation, what's inside parentheses, the f of 3x. It's a horizontal shrink, right? We know it's a stretch or a shrink because it's 3 times x. The multiplication means stretch or a shrink. Inside parentheses is sort of the opposite of what you think. So 3 multiplying by 3 you'd think would get bigger, but it gets smaller. And it's by factor of 1/3. Which means you multiply each x value by 1/3. And then we're going to do the vertical stretch, that's the 2, and which will multiply all of the output values by 2. Finally, apply the vertical shift, which will add 1 to all the output values. So here are my 3 steps. First, I'm going to take 1/3 of my x coordinates. 1/3 of 6 is 2. 1/3 of 12 is 4. 1/3 of 18 is 6. And 1/3 of 24 is 8. Then I said next we were going to double the outputs, double the y's. So 10 becomes 20, 14, 28, 15, 30, and 17, 34. Keep the x's, 2, 4, 6, 8. And then in my last step, the vertical shift adds 1 to all the outputs. So this is 2, 21, 4, 29, 6, 31, and 8, 35. And so my final table of values for G, 2, 4, 6, 8, and the Y values are 21, 29, 31, 35. Okay, so now we have some matching. This is my original graph F, and I have 9 transformations, formulas, and their graphs. So we want to match them. All right, so the simplest one, this is the simplest one, A, f of x plus 2. That would take my original f and move everything up 2. So I'm looking for something that looks exactly like f, but everything's up 2. So like this bottom point right here would be up 2 at the origin. So let's see if I can find something that looks like that. This one, right? That would be A. All right, then this one takes f and moves it left 2. So if you move this left 2 without changing the scale, this point right here is going to go off the graph. So you're looking for something that just looks like a check mark, right? Because this is going to get moved left 2. So it's all you're going to see is a check mark that starts all the way on the left. So that is this one. And then C, that moves my whole graph right 2. So you're looking for this exact picture, but this lowest point here is going to be over here at 2, -2. So let's see. Lowest point is over here at 2, -2. So that's C. All right, D does 2 transformations. It goes right 2 and up 2. So this bottom point, the minimum point of the graph, it's going to go right 2 and up 2. It's going to be at this point. And this one is going to go right 2, up 2. So that would land up here at -1, 3. And this one's going to be on the axis. So that is right here. D. Okay, 2 times f of x. That's going to double all the y values, which means everything is, all the y's are going to be twice as big. So this is going to be a vertical stretch by a factor of 2. So this is going to be lower, this is going to be higher, this is going to be higher. I'm looking for a stretched, vertically stretched version of the original, which would be this one, E. All right, f of 2x. Now that 2 is inside the parentheses, which means we're doing either a horizontal stretch or horizontal shrink. Inside things are always the opposite of what you expect, so that 2 times x you'd think would get bigger, but it gets smaller. We're looking for a horizontal shrink by a factor of 2. So think about putting your hand right here and squishing inwards. You're going to make it half as big as it is now. It's going to take up half as much space, so that would be this one, F. All right, y is -f of x. That's a reflection over the x-axis. You're taking all the y's and making them their opposites. So this point is going to be up here. This point is going to move right here. So you just flip it over the x-axis. And that is this one? No. This one. G. H is a reflection over the y-axis. So this point's going to move over here. And this point up here is going to move over here. Oh, that looks like this. It's the letter H, I think. All right, and then I have both, a reflection over y and a reflection over x. So this point right here is going to reflect over x to here, and then it's going to reflect over y and land right here. So you're going to have that low point right there. And that's this one, I. Okay, here I have 3 different parent functions. And each of these graphs is the result of applying one or more transformations to one of those parent functions. So for each graph, we want to identify the parent, state how the original graph has been transformed, and then try to find an equation. All right, so for number 1 here, that looks like the absolute value function. So y equals absolute value of x, that's my parent. And it looks like I just moved it left 1 unit. So my new function, my new equation would be y equals, to go left 1, I have to change the x. So it's going to be inside the function. So this is going to be the absolute value of x. And it's going to be the opposite of what I would think, so +1. Okay, the next one, the parent function here is the square root of x. It looks like I just shifted it up 2 units. So my new equation is going to be y equals square root of x plus 2. Number 3, the parent is y equals x squared. Looks like I went right 2 units. So my new equation is y equals, now I have to do the transformation before I square so that it's inside. So this is going to be x minus 2 and then squared. All right, here's absolute value again, but this time it looks like I went down 1.5. So my new equation will be y equals absolute of x minus 1.5. So now you put, since we're moving down, you put the minus 1.5 outside of the absolute value. Okay, here's another parent square root of x, and it looks like I went left 2 up 1. Left 2 up 1. So y equals, for the left 2, I have to put whatever change I need for that under the square root. So it's going to be x plus 2 in order to go left, and then plus 1 outside in order to move it up. Here I have absolute value again. And it looks like I went left 1, down 1. That's an and. Left 1 and down 1. My new equation would be absolute of x plus 1. That moves me left 1. And then down 1, minus 1. All right, 7. This looks like y equals x squared as the parent. It's got the general U shape of x squared. My origin is still at 0, 0, so I don't think that the transformation here is a shift. It's something else. So usually it might be helpful if I make myself a little XY chart. For x squared, I would have 0, 0, 1, 1, 2, 4, 3, 9, 4, 16, right? But what I actually have is 0, 0, 1, ooh, that might be a quarter, 1, 1/4, 2, 1, 3, 2 1/4. Some of these are 4, 4. So let's see. Used to be 1, now it's a quarter. It used to be 4, now it's 1. It used to be 9, now it's 2 1/4. Yeah, 2 1/4. And then it used to be 16, and now it's 4. So it looks like my y values are a quarter of what they used to be. So my transformation is a vertical shrink factor 1/4. So my equation will be y equals 1/4 x squared. Okay, here's an absolute value. That looks like I just flipped it over the x-axis. Reflection over the x-axis. And the way I write that equation is I just put a negative out in front. That will make all my y's the opposite of y. Okay, 9. My parent function looks like square root. And the transformation, it definitely looks like I went right 4, but it might be helpful if I sketch in the square root. So this is 0, 0, then 1, 1, 4, 2, 9, 3. So that is the parent function square root x. So it doesn't look like I only moved it left 4, right? It didn't only move left 4. It looks like it also shrank vertically. So we're going to say vertical shrink first. And then the factor, that's 1, 1. Looks like a half. Looks like the y coordinates are half of what they used to be. Factor a half. And then we went left 4. So my equation would be y equals, it's a vertical shrink, so I'm going to put a 1/2 on the outside. And then to go left 4, I put +4 under the square root. Right, this one also looks like square root x, but I think I reflected and then shifted. So reflect over the x-axis. Then I shifted up. So my original graph would look like this, 4, 2. There's square root. If you reflect it over x, it would go like that. And then we shift it up 2. So my new equation is y equals, a reflection over the x is a negative outside, and then x, and then up 2 is a +2 outside of the square root. All right, last thing, challenge activity. We have a new parent. You saw this in some of our lessons earlier, but it's not something that's formally going to be introduced until pre-calc. It's called the sine function. It's f of x equals sine of x, and it's a wave function. So g of x is -2 sine of 2 times x plus pi over 2 minus 1. So the graph of g of x is a transformation of sine of x, and we're going to fill in what these things, how we transform it. So all of the y values shrunk. That didn't happen because this 2 is how I'm going to stretch my y values. All my y values are stretched by a factor of 2. All the x values shrunk by a factor of, that is accurate, right? They're going to stretch by a factor, shrink by a factor of a half. The x values stretched, no they didn't, they shrunk. Okay. All of the y values moved up, no they didn't, because they moved down 1. And all the x values move left, pi over 2. They don't move right. So if I want to sketch a graph of this thing, I'm just gonna follow several key points, the zeros, the maxes, and the mins through the transformations indicated. Okay, so I know that my x values are all gonna go left by pi over 2. So I'm just gonna do one at a time here. My x values all go left by pi over 2. So I'll do my zeros first. Left. This one goes over here. This 0 goes over here. This 0 goes left pi over 2. This 0 goes left pi over 2. This 0 goes left pi over 2. All right, then I'll do the maxes. This max goes left pi over 2. This one goes over here. This one goes over here. And then the mins. This one goes over here. This one goes over here. This one goes left pi over 2, and that's it. All right, so I'm going to connect these, and this is just one of my 4 transformations that I need to do to get the final product. So I go left pi over 2. And let's see, I'll do the next piece in another color. This minus, oh, I got to change the shape before I shift. Ah, damn. Okay. All right, messed all that up. Don't do that yet. Right, the rule is you have to change shape by stretching and shrinking before you can do your shifting. Okay, so the -2 says to multiply my y values by -2. So I'm just going to go and pick all my key points and multiply the y's by -2. So 0 times -2 stays 0. So these zeros aren't going to change yet. And then my maxes and mins are all going to get twice as large. So They all go, instead of 1 and -1, they're going to be 2 and -2. All right, and I connect those. Okay, so that's my first step. Oh, I didn't multiply, I only multiplied by 2. So now I have to do the reflection over the x-axis. So the zeros stay where they are. And then the mins become maxes and the maxes become mins. You could have done this in one step. I forgot about the negative, so I'm just doing it in a second step here. So first I stretched by a factor of 2. Now I'm flipping over the x-axis. You could have in one fell swoop multiplied all the y's by -2. So now I've done the 2 and the negative. All right, now I'm going to do the 2 that's inside here. So that's my horizontal shrink by a factor of 1/2. So to take all my x values and multiply them by 1/2. And I'm looking at the red graph now. So this was step 1. The red is step 2. Now in blue, I'm going to take all my x values and make them 1/2. So 1/2 of 0 is still 0, so that stays. Now this min is going to be make the x 1/2 of what it was. This one, make the x 1/2 of what it was. This max, you got to go 1/2 the distance to the y-axis. This 0 goes 1/2 the distance it goes to there. This min goes 1/2 the way to the y-axis, and this 0 goes 1/2 to right there. And then I can do it on the negative side too. So that goes there, that goes there. This min right here moves 1/2 the distance to the y-axis, which is here. This 0 goes 1/2 the distance, it lands there. This max goes 1/2 the distance, it lands here. And this 0 goes 1/2 the distance, which lands here. Okay, that's step 3. So I changed my shape. I did the vertical stretch, the flip over the x-axis, and the horizontal compression. Next, I am going to do my shift left by pi over 2. Okay, so I have to move every point on the blue graph left pi over 2. So pi over 2 is 2 tick marks. So every blue dot has to move 2 tick marks to the left. So that. Do the zeros first. And then I'm going to do the maxes. 2 tick marks to the left. 2 tick marks. 2 tick marks. There we go. And then the mins all have to move 2 tick marks to the left. And then I connect my purple dots. There we go. I missed a couple. All right, and then my -1 takes all my purple dots and moves them down 1. Good color for the final picture here. Okay, everything moves down 1. So that one, Okay, moved all my purple dots down one, and now I just connect them with a nice smooth curve. So this teal graph that I did at the end, that's G. Took a lot of drawing to get there, but that's it.